All right, here are the practice problems from the homework for section 1-2, in case you need some extra guidance. Um, okay, so number 9, if we're evaluating negative 2 to the 5th power, notice you want to look for if this has or does not have parentheses. It does not have parentheses, so we need to follow the order of operations. So we have to do exponents first. So we're going to do 2 to the 5th power first and then make the answer negative. So that's like having negative and then 2 to the 5th power and working that out. So we're going to take 2 times 2 times 2 times 2 times 2. We're going to do that 5 times and then make the answer negative. So we get negative 32 as the answer for that problem. So just pay attention to whether it has parentheses or not. Okay, evaluate the expression for the given value of the variable. So we have this expression. They want us to evaluate it when m equals 6 for number 21. Also, if you notice that there's a red circle around a problem, that means that it is also worked out in the back of your book. So worked out step by step. So you can also use that if you need help on those kinds of problems to check your work. So we're going to plug in m equals 6 first. And remember, anytime we plug in a value, we want to use parentheses. So every place that I see an m, I'm going to use parentheses. All right, and then we need to do parentheses and then exponents. So since this set of parentheses is right here, we need to do that first. So within here, though, we have to do 2 times 6 first, which is 12 minus 9 cubed. So 12 minus 9 would be 3. So we have 3 to the 3rd power, which is 3 times 3 times 3, which would be 27. So we have 8 times 6 plus 27. So then we can work out 8 times 6, which would be 48 plus 27. So we get 8 plus 7 is 15 plus 60, so 75 is our answer. All right, simplifying expressions. Now we're using variables. So we need to find our like terms and put them together. Also, you'll notice that we have parentheses in here, so there's an extra step that we have to do before we combine like terms. So anytime you see parentheses like this, that means you have to distribute. So we're going to take and distribute these here. So we're going to end up with 4p squared minus 12p minus 9p squared plus, and then 3 times 4p would be 12p, and 3 times 7 would be 21. So now we can look and see what terms we have alike. You always want to write your answer in what's called standard form. So you want to start with the one that has the highest exponent and then work your way down. So the highest exponent right here would be p squared. So I'm going to start with all of those and put those together. So 4p squared minus 9p squared would be negative 5p squared. Okay, then I'm going to go down to the p's. So I have negative 12p plus 12p. Well, those are just going to cancel out. And so then all I have left is plus 21. So this is going to be my final answer because I can't simplify any further because they are not like terms. All right, you started driving a used car when the odometer reads 96,882 miles. After a typical month of driving, the reading is 97,057. Write an expression for the reading on the odometer after m months, assuming the amount you drive each month is the same. Predict the reading after 12 months. So let's break that down. So let's go back and talk about what we know. Okay, we know that we are starting with 96,882, and after 1 month, we have 97,057. 97,057. So automatically right there, I can see that there's a difference. So I'm probably going to find out what that difference is. So if I take 97,057 minus 96,882, I'm going to go ahead and subtract this. And so I have 97,057 minus 96,882 would be 175. You can double check your answer if you need to. Um, and then it says write an expression for the reading on the odometer after m months, assuming the amount you drive each month is the same. So right here it says we have to write an expression after m months. So whenever they give you a variable, they want you to put that variable in the expression. So we're trying to figure out no matter how many months I'm trying to figure out is going to be on my odometer, like the amount of miles after so many months, I want to make an expression that will work for anything. So I can find out what it is after 10 months, what it is after 24 months, and so on. So I know about after a month I put 175 miles on there. That's not very much. So we're assuming that the amount that you drive each month is the same. So each month I'm putting on about 175 miles. So if I want to figure out um, the reading on the odometer after m months, I'm starting with my beginning initial value and then I'm adding to it every so many months. So I know I'm going to start with 96,882 and then I'm going to add on however many miles I'm driving. Well, I know I'm driving 175 miles per month, so I'm going to use M for months there. And then if I want to drive 6 months and figure out what it's going to be, I can plug in 6 for M. If I want to drive 12 months, I can plug in 12 for M, and it will give me the exact amount that's going to be on my odometer. So this is my answer for the expression. And then it says to predict the reading after 12 months. So to figure that out, I would have to plug in 12 for M and work it out. So I'm going to have 96,882 plus 175 times 12. So if I multiply 175 times 12 and then add that to 96,882, then I end up with 98,982 miles. So that's what would read on my odometer after 12 months. All right, one more question. Find the least common denominator, LCD, of the fractions. Now this is review for you guys, but in case you forgot what the least common denominator is, it has to be the common denominator for all three, but it has to be the lowest number possible. Well, I have 2, 5, and 10 as my denominators. So I want to figure out, I need to change 2, 5, and 10 to be all the same number. So something you can do is you can list out the least common multiples, or the multiples of these numbers. So I have 2, 4, 6, 8, 10, 12, and so on. Those are multiples of 2. Multiples of 5 would be 5, 10, 15, and so on. And then we have 10, 20, 30, and so on. So you can see that all of these have 10 in common. So I could change all of them to be a 10 if I wanted to. So the least common denominator then would be 10. So if you think about what you can change all of these numbers into be and the smallest one possible, that's how you would find it. All right, if you guys have more questions, feel free to consult me in class. Thank you.